So we're now into our last three sections for the review for the final. And let's just get started. We're going to, all of these, what they have in common is they're really finding area underneath the curve or area between two curves. So that's what we'll start off with is, two curves are there. We want the area between them. So we're going to subtract the two. The next section after that is getting an average value. So it's getting the area under the curve, but the average, so it's turning it into a rectangle is what an average does. So we divide by the limit subtracted. You'll see that. And then finally, we do something called a surplus. And we have consumer surplus and what's the other? Producer surplus. And just think about it. Consumer surplus, consumers will have a surplus whenever the price is lower than what they were willing to pay. Okay, so what we're the subtraction, it's really just area between two curves. It's the consumer minus the price. In producer surplus, it's the other way around. The price has to actually be higher than what they were willing to sell it for. So their curve comes this way. So it's going to be the price minus the surplus, the producer's curve. Okay, so it's really just area between two curves, but an applied part of it. So as we go through these first section on area between two curves, see how that relates when you get to the last section. Approach those problems just as if they were area between two curve problems. I didn't notice that at first because a lot of times you're going through the class so quickly. I mean, when I learned it myself, I just looked at it as something different. You memorize these formulas to go forward. But that's why I want you to see is these, I grouped these last topics into basically three main topics. We've really just looked at three types of problems. And then, so within each of those three types that I've reviewed, there are three sort of sub-problems. So let's go ahead and take a look at these sub-problems. We're going to find my window over here. I think it's here. Yes, we are. So area between two curves. So we're going to start off with this one. So undo that one. Good. I've got my pins ready. And we want to find the region enclosed by these two curves. This is one curve, so we'll make this f of x, or since we're using the graphing calculator, we'll make this one y1 and this one y2. Okay, and the first thing we do is we're going to graph these two to see whether it's y1 on top or y2 on top, and whether they switch, we need to find, so we will graph. We will find intersections, because in this case, since it literally is just the area between these two, we're looking for those intersection points, and those also will become our bounds of integration. And then we're going to make a decision, decide which is on top, which one is greater, but graphically is on top. That's the one. We take that minus the other one, and then we integrate. Oops, 4. Then integrate. Most of this will be done with the graphing calculator. Again, we can write it out, but we definitely need the graphing calculator to be able to perform these. So I've got my list covered, but so if you're not sure, there it is. You could always pause the video, remember. That's the nice thing about this. Live, you can't really pause me when I'm live, right? Okay, so we're just going to put this first one in here. So we go to Y, we'll turn the thing on. Actually, it's already in here. I made an error when I put this in, so I want you to see exactly, because this is, if you don't have the right things in, you're not going to get the right answer. And that's generally what I find is you'll get the concept down, but you'll make an entry error, just like I did the first time I did this. Um, I've gotten good at finding my errors, but that's only because I made so many. Okay, so we want the negative. I just point out that it's this negative. Some people will put the subtraction key. That will cause you some kind of an error. What is it called? It's called a syntax error because it's the wrong kind. So you start to see what kind of errors. It does give you a few clues. So syntax error means you entered something wrong. There's other kind of errors as well. And then we enter this one, 2x squared. Come over here, plus 9x minus 4. So we do a check. Okay, now that's looking better. I'm going to graph it. Now I'm going to do a zoom standard and I'll show you because part of this is getting a good fitting window. This one does not fit perfectly into a standard window, but it does okay. We can see the two and we can see an intersection. We got this thin sliver. So what I'm going to do is I'm going to change my window. I don't need it to be this wide. This is going from negative 10 to 10 in the x direction. Let me bring it down maybe negative 5 to 5. So I'm going to squeeze in this way. From the top, though, I don't see this bottom intersection, and I want to see that. So I'm going to bring the bottom of my screen down as well. So we'll do that all with the window key. So I'm going to bring the sides in. That's the x. X minimum is going to be minus 5. X max is going to be positive 5. And then my y minimum, that'll bring the bottom of my screen down. Let's make that negative 15. I think that should be enough. I was satisfied with the top. We'll leave that at 10. Now I hit graph again, and look, the graph looks different, but it's exactly the same graph. And notice I do see the bottom here, this bottom intersection and this one. Now we could have come in a little bit more if you wanted to. This is all up to you, but I think we can see enough of this at this point. So what was our next step? We graph it. Then we want to find the intersections. Okay, we find intersections. We can see them there. We go second calc, number 5, intersect. That's our tool we're going to use. What I want to do is I want to find this one to the left first. So I'm going to hit the left or right arrow key. In this case, the left one, because I want to come down to the left. Don't hit the up or down. When you hit the up or down arrow, you actually switch curves. Notice I went from Y1 to Y2 and back and forth. So you've got to hit the left arrow. We're going to hit enter because it's asking, is this the first curve? We say yes by hitting the enter curve. And it then asks for the second curve. I guess I could have been on Y2. I say yes, and then a guess. So then it finds the intersection of those two curves. X equals negative 2. So I'm going to put that over here. X equals negative 2 is one intersection point, and that's going to be one of our boundaries. Okay, I need to find the other, so I go second calc again, and number 5. And again, if you know these things, that's great. You can always fast forward past these in the video, but I just want to make sure, at least with this first one, we go through all the details. So I want to find this intersection, so I got to get my little Spider-Man, Spider-Woman, Spider guy, Spider thing up towards here. So I said enter, enter, enter 3 times, and I get my intersections at x equals 1. So I've got my 2 intersections. Now this one, since it's a region and closing, these are going to be our limits of integration. Secondly, now let's decide which one's on top and which one's on the bottom. Okay, so one way to do that is if you hit the trace key, it's going to be on one of them. And I can see this one is the top one, and up here it tells me that's Y1. Okay, so Y1 is on top, and if I go down, Y2 is on bottom. So I want Y1 minus Y2. Okay, Y1 minus Y2. So what we have done, if we were going to do this by hand, which you could, we're going to get the integral from negative 2 to 1. Y1 goes in first, so this one goes in first, minus x squared plus 6x plus 2 and we're going to subtract. Now it's important to have this parentheses. We want to subtract the whole thing. 2x squared plus 9x minus 4 dx. If you want to simplify this, we're going to get back to the calculator in a moment here, and I'm actually going to just, since I've got it entered, I'm going to use this, and I'll show you how to do that. But I also want you to understand the analytical way of going through with the symbols. So now we're going to get like terms. So this negative comes here, so we've got a -1 and a -2. That's going to be -3x squared. We've got a +6. This is going to come over, make it a -9. That gives us a -3x, a +2, and a +4. We're going to have a +6. So the other thing is you could graph this going from -2 to 1, or you could integrate this. And again, we'll just get some practice with this. This integrates into -3. 2 plus 1 is 3 over 3. This is -3x to the 1. 1 plus 1 is 2 divided by 2. And this just becomes 6x. And then we're going to go from -2 to 1. Okay, so you could then simplify and go through, plug in the 1 for the front part, plug in the 2 for the back part, do the subtraction, which is great. What I'm going to do is I'm going to continue with the graphical mid, because that's really the way that it'll help you understand, I think, more clearly. Okay, so then what we do, since we know what's on top and what's on bottom, we go to y equals. We're going to come down here to y3, and we're going to say give us a y variable. So notice I hit the vars key, variable key. Go over to y vars and function, and the first one I want is y1. Then I can subtract. I hit the vars key again, y vars function. Now I go down to y2. So I'm going to take y1 minus y2. It's going to be messy there because notice I've got 3 graphs going on. So I'm going to come here, and on the equal sign I hit enter. That turns it off. Up here I hit enter. It turns it off. So if you ever go to try to graph something and there's no, this equal sign's off, it's not going to graph it. It still has it in memory, which we need it. Don't delete it, because otherwise this is meaningless, right? We need it in there, but we don't want it to show on the graph. It will just show this new graph, which is a subtraction of the 2, which is this function right here. Yeah, you can see that. -3, oops, I gotta watch my head here a little bit. -3x squared minus 3x. Okay, so that's what we're going to see. We'll hit the graph. There it is. And now we get the graph, the area underneath this curve, and we do that by going second calc number 7. The lower limit, we've got that is -2. Plug that in, hit enter. The upper limit is 1. That's what it's asking for now, so we hit 1, enter, and it fills it in, and it tells us that our answer is 13.5. Okay, what I'm going to do, actually I should have done this before, but let me take a screenshot of this. We're going to paste that in here. And what I'm going to do is I'm going to do a screenshot of the y equals as well. So we come here, just that one. Let's go ahead and do a screenshot of that one. So we know what we got put in here. So this is kind of like showing your work. Let's move this guy back up. That's good. And we've got our answer right there, 13.5. Now, if this is a multiple choice, that's good enough. We've got our answer. But do know if this was an essay question, we'd want to see this work over here, at least with the setup. And then, you know, maybe a few sketches. It'd be good to sketch, if you use your calculator, sketch a graph of it. That's what I'm going to go with. Okay, so I think from here on in, we can do this, again, what we consider by hand, but it's, we would say symbolically, working through it. Over here, what we're doing is graphically. Personally, I like doing both, sort of, but if I had a choice, I would go with the graphical because you see so much more information. You're really processing so much more information than the symbols can give us. The symbols will give us this 13.5 and we're done, but we don't see the pattern or relationship as much. Okay, I know you guys just want to review for the test, so let's keep moving forward. And we'll, but I just wanted to give that one sort of slow through. To the rest are basically this with a few little extras thrown in there that we'll get through. Okay, so now let's pick up a little speed here, and of course you can always fast forward, right? So let's get this out of the way. So find the area of the region enclosed by the curves. Again, we've got two graphs, two curves, two functions. We're going to graph them first, figure out which one's on top, which one's on bottom, and see if they change. This one might, well, I don't know. Let's just graph it. That's the first step. You have to graph it. And someone, well, if I don't have a graphing calculator, well, then you're going to have to plug in a bunch of X and Y values and compare those, which I guess that's the way we used to do it. I learned in the early 80s was when I'm going to leave this Y1 minus Y2. We might save us some time. We could turn it off. And then while I'm here, this might be something you wanted to save yourself some time. I'm going to do a Y2 minus Y1. Okay, so this is something you could actually do before the test down here because you probably aren't going to be using these. All right, vars. And I think this is just, you have to know what you're doing, right? So this is a Y2 minus Y1. I'm going to turn it off. I have to know which one I'm going to use for which interval. Okay, so those are one's on top, one's on the bottom, or the other. So we'll see. We'll use probably both Y3 and Y4 at some point during this review. So I put the Y, and I'll come over here. I'll say that this is Y1. And I'll call this Y2. Okay, so got to figure out, there's got to be a stay on top. Let's see. I don't know. I haven't found it yet. So we put in x squared, arrow over, subtract x. Yeah, so make sure you're not just putting them all up in the exponent like I do sometimes. Plus 5. So that's the first one. That's good. Again, make sure you've got the right one in, and then it's just x plus 8. It's going to be a linear function and a quadratic function. Okay, we're going to take a look, see what we got. I'm going to do a zoom standard, zoom number 6, just to kind of get my window negative 10 to 10, negative 10 to 10, and see if that works. It's pretty good, but I would like to be a little bit higher. To see this actual intersection. I could do it without it, but again, graphing is a visual way of solving, so you should be able to see everything. So I'm going to go and I'm going to raise the window a little bit higher by going to y equals, and that's our y max. Let's make that 15. I think that will be high enough. Just to see things a little better, I'm going to go negative 5 to 5 because I'm going to squeeze in at the same time, just so we get better use of our real estate here. So we see the two intersections. This is nicely centered. Again, as long as you can see it, it's fine, but being a graphical solution, the better we see it, the better. Okay, second step. Now that we've graphed it, well, I guess you go to the trace. The bottom curve here, it tells us that's Y1. Wow, Y2 is on top. Okay, so we want to remember that we're going to be going y2 minus y1 for this one. What do we do next? We need our limits of integration, which are the intersection points. So we go second calc, number 5. First curve, I'm close enough, so I'm just going to hit enter, enter, and then for my guess, I hit enter, and it comes and it finds the lower intersection. So again, we're integrating y2 minus y1 dx, and I should have checked to see what that was first at -1. Till I have to find the next one. Notice I don't care about the y, I just really care about the x, because once I do the subtraction, this point you're going to see gets, we're basically, when we do the subtraction, this one minus, it gets 0, so it's on the x-axis. This one will also be on the x-axis, and then we'll get the area under the curve. All right, so -1, I need the other intersection, and this time I need the spider to get closer to that other intersection that I can see right there. Let's walk them over. Enter, jumps to the other one, enter, ask for a guess, enter, and then my intersection's at 3. So that's my other limit, is I'm going from -1 to 3 on this, for this graph, okay? That will give me my intersection. And again, you could write the full thing out. It's this, so it's, again, integrate -1 to 3. It's x plus 8 minus x squared minus x plus 5 dx. This negative comes onto here, and there's no x squared term, so we'll bring that to the front. So we get a minus x squared. This is a minus and a minus, so there's a, this becomes a plus x and a plus x, so that's a plus 2x. We have this 8, and this comes over here, makes this a -5. 8 minus 5 is a plus 3. So this is the graph we're going to see when we do y2 minus y1. We'll see this graph, so it's an upside down, it's this opening downward. It's just going to be a quadratic. Again, -1 and 3 are going to be the x-intercepts. We'll find the area under the curve, and we'll have our answer. So this is where I'm going to take a screenshot while I'm here so that we can see it doesn't have, oops, let's see. There we go. Getting a little bit better at this, I think. Okay, so find the intersection. There we go. We can make it, I guess, a little smaller. Doesn't need to take up that much space. Not that bad. Okay. Next thing is we set up that we want, sorry, I don't want that one. I want y2 minus y1. So I'm going to turn this one off and this one off so they don't graph. They're still there. Don't delete them. Come down to the y2 minus y1. We're going to turn that one on. Okay, so you'll see if you do the other one, you'll get a, it'll be going the other way and you'll get a negative answer. So it's not that it's terrible, but it just, you would see it. Okay, we want the area under the curve. It's going to be a positive value here. It's going from -1 to 3. And so we go second calc, number 7, the integration key. The lower limit is -1. The upper limit is 3. And there we go. It's 10.666. Hopefully you recognize this repeating decimal as a third. I suppose I should have taken a snapshot of that as well, but let's do this while we're at it. Leave room. I'm going to put the put one more in between here. Let's go back to the y equals and just show, I don't know why it keeps going back there. just show which we've got, what we have. Oops, I don't want that yet. Let's see. Oops, I didn't want that. What was it? It was x squared minus x plus 5. There we go. That'll be a good enough screenshot showing what we're doing. Oops. Make this one. And while we're at it, let's make this one. Let's go with tight, and then I can put them side by side. That's good enough. This one tight as well, and that way we can move them around. There we go. It'd be nice on a test you could just do this and show me exactly what you got. But anyway, that's our answer. And again, what we'll do is come down here. It is 10.67, we'll say, rounded to 2 decimal places, recognizing that this is a third. If you need to be able to recognize it, it's actually 2/3, sorry. 10 plus 2/3, which would be the mixed number 10 and 2/3. So you can turn it to an improper fraction. You take 3 times 10 is 30 plus the 2 that's there. So you might see the answer 32/3. Again, if you divide this, you'll get 10.66 as well. So multiple choice, it could be this, it could be this. Okay. But just be able to spot it. Okay. Now, let's see, 17. The area of the region between this curve and this curve. But now they're telling us they only want to go from x equals -1 to x equals 1. So we've got limits of integration. When we've got ones like this, we're looking at a specific region, -1 to 1. It is possible that they've intersected and that the curves have switched which one's on top. So we need to, maybe not this one, but anyway, we're going to check it out. So again, we'll graph both of these. So we'll call this one y1, this one y2. Find the intersection point still, or see if we need to. We might not need those intersection points, but we definitely need to know which one's on top. I think this one's going to be on top, but let's just graph it to find out. Okay, so I'm going to clear off y1 and y2. I'm going to leave our y3 and y4, but I'm going to turn them both off. Okay, so you hit the equal sign and now they're off. y1, I'm going to put x squared. And y2, I will put just the number -1. That'll be a horizontal line at -1. I'm going to leave the graph at what it was. Yeah, see the area between these two curves. They don't actually intersect, so you can't find them. That's why they needed to give us these boundaries. But I do see clearly, hopefully, that y1 is on top of y2. Oops, what did it do to me? To y2. There we go. Okay, so we're doing y1 minus y2, and the limits of integration are given to us from -1 to 1. We don't have to worry about switching or of which function is going to be on top or not. So, but if you want, I'm going to come in a little bit. Let's, from the y's, I'm going to come down. Yeah, let's just make this -5 to 5. Just see it a little bit better. And again, we'll get from here to here is what we're going to be looking at. We go back to our y equals. We want y1 on top, y2 on the bottom. And here's where the benefit is. We just have to turn on this one. You could leave these other ones on, but it gets messy. And if you had a color graphing calculator, it wouldn't be so bad. So notice I've turned these off. Y3 is on, y1 minus y2. So when I go to graph it, I'm going to see area above the curve. And what I want is my limits going from -1 to 1. So that'll be number 7, integration, lower limit, -1, and that comes right from this part here. Upper limit, +1, that comes from the limit there. Fills it in. That's what I like about this 2.6667. And again, you know that so it should be dx 2.67, which is 2 2/3. 3 times 2 is 6. 6 plus 2 is 8. So that's going to be the same thing as 8/3. You might see an answer, 8/3. You might see this as your answer. Multiple choice, you choose either one, right? So again, let me take a snapshot of this while we're at it. And then Control V to paste it. Wait, where did it put it? Whoops. Let's undo that. I mean, I gotta be down here. So Control V to paste it there. Make it a little bit smaller, doesn't need to be that big. We'll make it nice and tight so it fits well. Let's move it back up here. There we go. Just get it all organized. You can always fast forward, right? Now give myself a little bit more room here. And then I also want to take a snapshot just so you see what the setup was with the y equals. And let me, which one's turned on. Hopefully you'll be able to remember that. Because I'll also post these sheets separately so you could just take a look maybe as lecture notes to review them. Do this one, we'll do it tight. Where'd you go? There it went way up there. Go. Come on. Make sure these guys are in the right place. There we go. So we didn't really need to find intersections on this one, but we did need to find which one's on top, which one's on bottom. That was y1 minus y2, and we get the intersection over there. Okay, so for this one, I'll do these separate videos so you can take a break. This one we're given as a multiple choice. So this is nice. It gives us a little bit of practice for what we might face. Now, they have given us the answer, so I apologize. I didn't go through and undo this, but it gives you the practice, okay? So we want the area between the regions of the curve, y squared and y equals 1. So it's similar to what we just did, except instead of being -1, it's up here. So which one's on top? In this case, if we call this y2, we call this y1, y2 is on top, right? Here's our y2. This one here is y1. And it wants to go from -1 this time until 2. So we're going to get this intersection. Now the problem with this is, well, I don't know if it's a problem, but we want the area between the curves, so we see this happening. Now last time we stopped at 1, but this time they're stopping at 2, so they want the area here. Notice what happens. The area changes. So this part now, y1 is on top and y2 is on the bottom. So this is one of those where we're going to actually have two different integrations. Okay, and this one here is going to go from -1 to 1. The second one's going to go from 1 to 2, and that's when we add it. Okay, so going from 1 to 2, we add the subtraction y1 minus y2. And again, each of these should have a dx. Okay, so we see it's got to be 1. So, you know, this doesn't make sense going from -1 all the way to 2. You've got this intersection here, so those won't make sense. So we know we have two of them. This one's going from -1 to 1, 1 to 2, and the difference between these is which one is which, right? They've got these backwards, and so this one, which one's y2? So you might want to write it out. y2 is going to be 1 minus x squared, should be first. That's this one. See, that's why you want to be able to set these up as well. And the second one, going from 1 to 2, is y1, which is x squared, then minus the 1, which is this one. So we can recognize that that's going to be C. And so as you take the final exam, you'll have questions similar like this, where there's the multiple choice. You just have to choose the right one. For that, the work is not required, so you could do it. If you wanted to, you could have graphed this. Of course, graphing it, you get a numerical answer. That's not going to necessarily help you with these, but they'll give you the graph. You've got to be able to choose the correct answer. Okay, so do those. This is really getting into conceptually helping you understand how to set up the problems. Okay, so I'm going to take a little break, get a little more coffee, and in this video, get it processing, and then I'll start the one for which one are we doing next. We're going to do all the way down here. We're going to go to section 14.3 average value, which we'll see is pretty much related to what we've been doing here. All right, take a little break.